Hey Algebra 1, welcome to notes number 3. Our learning target today is I can solve equations with variables on both sides, including special cases. When we are solving an equation that has variables on both sides, our goal is to try and make it look like a two-step equation. The first thing that we'll have to do is simplify on both sides of the equal sign if necessary. And then we're going to move all of our variable terms to one side of the equation. We'll either use our inverse operations to move them to the left or to move them to the right. And after that, we'll have a normal two-step equation that we can solve. So we're going to do two examples together, and then we're going to look at what some special cases are. For our first example, I'm going to start by drawing a line through my equal sign. My first step would be to simplify on both sides of my equal sign. Fortunately for me, I don't have anything to simplify on either side. I don't have any like terms, I don't have any parentheses, so I don't need to simplify. My next step is to move the variable terms to one side of the equation. In this example, I have a 4x term on the left, and I have a 7x term on the right. So I can choose to use my inverse operations to move my 7x to the right, to the left, or to move my 4x to the right. It doesn't matter which one I pick. No matter what, my answer is going to end up being the same. I'm going to show you both options just so you can see the difference. So for the first one, I am going to move my 7x term over to the left because usually when we see two-step equations, our variables are on the left. So to cancel out my positive 7x, I need to subtract 7x on both sides. 4x minus 7x is negative 3x. I'll bring down my plus 1, bring down my equal sign, bring down my negative 5. So something that I want you to notice here. When we subtracted 7x on both sides, I made sure to line up my x terms, because it's these terms that I'm actually subtracting. I didn't put the 7x over here underneath the positive 1 because it's not a like term with positive 1. It's a like term with my 4x. Now that I've done that, I have a normal two-step equation. Negative 3x plus 1 equals negative 5. My first step is to subtract 1 on both sides, and I get negative 3x equals negative 6. My second step is to divide by negative 3 on both sides. I get x equals positive 2. Okay, here's the other option. I could also solve this equation. I'm going to do the same exact one, except I'm going to change the first step. So now instead of moving my 7x term, I'm going to move the 4x. To cancel out a positive 4x, I have to subtract 4x on both sides. 4x minus 4x is 0, so I'll bring down my positive 1, bring down my equal sign. 7x minus 4x is 3x, and I'll bring down the negative 5. From here, I just have a normal two-step equation. So my first step will be to add 5 to both sides. Negative 5 and positive 5 is 0, so I end up with 6 equals 3x. Now I can divide by 3 on both sides, and x equals 2. So we get the same solution no matter which way you solve the equation. It doesn't matter how you start. To check our work, I'm going to go back to my original equation. And if everything has gone as planned, then both sides of my equation should be equal to each other. So anywhere there's an x, I'm going to substitute in my answer in parentheses. So on the left side, I have 4 times 2, which is 8, plus 1. On the right side, I have 7 times 2, that's 14, minus 5. 8 plus 1 is 9. 14 minus 5 is also 9. So my equation is correct. It balances. It's the same on both sides. Okay, if we check out our second example, our equation looks a little bit longer here. There's more stuff going on. Before I can start trying to solve, I need to simplify both sides of my equation. So if I start on the left side, I have some like terms here. I have a -7 and a +5 that I can combine. This positive 4x doesn't have a like term. So I'm going to bring the 4x down in front. And then when I combine my like terms of -7 and +5, that's -2. My equal sign is still happening in the middle. On the right side, I don't have any like terms, but I do have a number that needs to be distributed. So I'll distribute a 2 into my parentheses. 2 times 4x is 8x. 2 times -5 is -10. Now we have our simplified equation, and I'm going to make this look like a two-step equation. So I have variables on both sides, which I don't want. I can either cancel out the 4x or cancel out the 8x. As we saw in the first example, it doesn't matter which one I start with. I just need to choose one. So to try and keep things positive, I'm going to cancel out the 4x. So that means on both sides of my equation, I'm subtracting 4x. 4x minus 4x is 0. I'll bring down my -2, bring down my equal sign. 8x minus 4x is 4x, and I'll bring down -10. Now I have a two-step equation. My first step will be to add 10 to both sides. -2 plus 10 is 12. Bring down, oh no it's not. Nope, definitely not. -2 plus 10 is 8. And I'll bring down my 4x on this side. Now both sides have to be divided by 4. And x equals 2. To check my work, anywhere there is an x in my original equation, so I'm going to go back to the very first one I started with before I simplified anything. Anywhere there's an x, I'm going to substitute in a 2. When I start simplifying on the left side, 4 times 2 is 8, so I have -7 plus 8 plus 5. On the right side, I have a lot of stuff in parentheses, but I'm going to start with the 4 times 2. So this ends up being 8 minus 5 in my parentheses. -7 plus 8 is +1. +1 plus 5 is 6. On the right side, I still have stuff in my parentheses, so 8 minus 5 is 3. So the left side's already done, that's just 6. Right side, I end up with 2 times 3, that's also 6. So my equation is balanced, both sides are the same. So one way we think of equations is as scales, keeping things balanced and the same on both sides. So if we look at these problems, I can think of these blank boxes as x. This is what I'm trying to fill in. What number fits in this box that will keep my scales balanced? So if we look at the first problem, I have a 6 on the left. I have a 6 on the right with 2 x's, and I have 4 x's on the left. So this would look like the equation 4x equals 2x plus 6. To keep this scale balanced, well, I can just kind of think about it. What number would fit into these boxes to keep it the same on both sides? Well, I have 4 boxes on the left, I only have 2 boxes on the right, and I have a 6. So this 6 is probably worth 2 boxes. So let's see, does that work? If I call each of these 3, what do I end up with here? 12 on this side. These are also 3, 6 plus 6, I end up with 12 on that side. So my solution that keeps my scale balanced is 3. If we look at the algebra, we have variables on both sides, So I'm going to cancel out one of my variable terms. 2x minus 2x is 0. I'll bring down the 6. 4x minus 2x is 2x. Divide by 2 on both sides, and x equals 3, as expected. If I look at my second problem, my equation here looks like I have an x plus 3 on the left, and I have an x plus 5 on the right. So if I think about the problem, what number can I fill into these boxes to keep my scale balanced? Well, let's see, if I try 1 on both sides, well now 1 plus 3, this side is 4, 1 plus 5, that side's 6. So that's not gonna work. If I try 0, what happens if I put in a 0? I end up with a 3 on this side and a 5 on that side. That's not gonna work. There's actually not a number that I can fill in here to keep my scales balanced. This kind of problem has no solution. And if we look at the algebra of what happens, I have variables on both sides, so I need to cancel one out. So I'll subtract an x. And what happens here is that x minus x is 0, so I'm just left with positive 3. X minus x, still 0. I'm left with positive 5. And this statement is not true. 3 does not equal 5, so I would say I have no solution. Our other special case happens when we have infinite solutions. So for this problem, my scales look like I have an x and a 4 on each side. So x plus 4 equals x plus 4. If I think about a number that will fit in here, let's try 1 again. If I put 1 on each side, 1 plus 4 is 5, 1 plus 4 is 5. That works. Does it still work if I put in a 0? 0 on this side, 0 on this side, 0 plus 4 is 4, 0 plus 4 is 4. Yeah, that still works. It's always going to be the same on both sides, no matter what number I put in. So if I put in 100 on each side, 100 plus 4 is 104, 100 plus 4 is 104. No matter what number I fill in for x, my scale is going to be balanced. When we look at the algebra for what happens here, I have variables on both sides, so I need to cancel one out. So I'll subtract x on both sides. X minus x is 0. I have a 4 left. X minus x is 0. I have a 4 left. And this statement that 4 equals 4, that's totally true. In this case, I have infinite solutions. We saw that I could fill in any number for x. So when you're solving these algebraically, the difference between our special cases and our one solution case is that in both of these, when we were solving it, all of our x's canceled out. When I had no solution, all my variables canceled out and I was left with a false statement. 3 does not equal 5. When I had infinite solutions, all my x's canceled out and I had a true statement. 4 equals 4. When you have one solution, you're going to get to the bottom of your problem and still have an x equals, because that's your one solution. So be careful with these. Be careful when your x's are canceling out. You need to make sure that if all your variables cancel out, check if your final statement is true or false. That will tell you if you have no solution or if you have infinite solutions.